Welcome everyone, and thank you for joining us today from different geography. Today we are going to talk about an interesting topic, how companies can build and scale real production-ready RAG assistants without spending months on heavy engineering. This session is practical, hands-on, and engineering-led, and we will also show you a live demo of a full production pipeline. Let me first introduce the team. I am Raj. I'm the host and an enterprise architect within Cloudaeon. Over to you, Amol.
Thanks, Raj. Hi, guys. This is Amol here. I lead AI architecture and delivery work at Cloudaeon. Thank you. Over to you, Ashutosh.
Hi everyone, I'm Ashutosh. I'm an AI engineer here at Cloudaeon, and today I will be showing you a demo of our application.
Yeah. Thank you, Amol and Asutosh, for joining in. Okay, to begin, let's talk about something we see in every project, right? POC looks simple, but when we move to the production, it's not. Amol, can you explain why?
Thanks, Raj. You see, most POCs look easy, and that is because the setup is usually small, couple of files, you bring it into the system, done some embedding, put it into the vector database, ask some few questions. But production is completely different game. First of all, your data is not sitting in one nice single file. It lives in many places. It comes in many format, and there are a lot of embedded things inside the files. And it keeps changing every single day. Then you have access level policies you need to apply on this data. The system must ensure it shows right data to right people. You cannot get that wrong. On top of that, the answer must be accurate. So like the accuracy is important there, right? That's why doing RAG in real production or in any enterprise organization is much harder than a quick demo.
So, Samuel, as you mentioned about the complexity of single file, multi-file, multi-source, and giving the right person the right data at the right time with accurately, and also everything under the user cost control. So, Amol, how does this complexity affects the time and effort needed to build a RAG internally?
It's a great question, and I would say this is in-house build versus accelerated delivery. If a team tries to build everything from scratch, they will spend first 16 to 20 weeks just on plumbing. Not on the business value, just the plumbing. They spend all the time on data ingestion, creating embedding, turning that embedded data into the vector database, and figuring out access rule. It's a lot of foundation work. But with the accelerator led approach, we have already built and tested that foundation. So instead of 16 or 20 weeks, we bring that delivery down time down to under 4 weeks. And the important part is the team keeps full control. It's your data, your IP, your system. Now let me show you the actual component that make this speed possible. So here are the building blocks we have already engineered for you. As you can see, these are all pre-built production tested components. You start from getting the data from your source system. So we already built these pipelines for you. Then you have to do the chunking and embedding. We already have component built for that. Then even we build prompt template and caching, so you can save on your time and money. Then we have built some synthetic Q&A generator, synthetic data Q&A generator. That's where actual your testing and the accuracy is happening. So we already pre-built that component also, so you can be rest assured, or you get a good sort of a kind of a pointer where you can say that, okay, is my RAG application working as expected or not? Should we really kind of push it to the wider audience or not? Then we have a monitoring and cost metrics also, because in an enterprise setup it's kind of a spiral up, like the cost gets spiral up quite fast, so you need to kind of keep in check on that side of things also. And of course governance and access control is kind of a pre-built on it, so people access the data what they're supposed to access. So you have a kind of a tighter control according to your organization's policies. Then you can see like vector store, vector database is kind of a main part where all your kind of data is going to store. while doing the RAG Q&A. So you have various choices to use what vector databases you want to use in our accelerator. So we are kind of a pretty much technology agnostic, and we want to keep it that way. So you choose your tools, and we have all of this available in our accelerator. Let's see how all of these can kind of come together in RAG lifecycle. This diagram shows the full journey of production system. If you follow the circle, we start by bringing in data and preparing it. We create the embedding and we store them securely in vector database. Then the retrieval pipeline finds the right information. The RAG engine creates the response, but we don't stop there. We check the quality automatically. We present the output through the UI, and throughout the whole process, we are monitoring everything to ensure the system stays healthy. You are now going to see this entire flow in live demo. Ashutosh, over to you, and hope demo gods are with you.
Thanks, Amol. So now I'll walk you through this whole full pipeline that we've built, and along with the data ingestion part and how we ingest that into or convert them into embeddings and then store them into vector database, and then how we exactly retrieve this data from these vector databases and how we prompt them to get the answers out of it. We'll also look into how we are going to evaluate these answers based on the factoids that we get from the retriever. And then how do we exactly generate the synthetic data to test these data sources. So yeah, let's get right into it. This is our login page where we put credentials. Let me put mine so that we can get in. Perfect. So this lands us to this page, which is a Q&A playground. And here we can see we can select the data set and along with LLM to start asking questions about that data set. But as we all know, in a RAG pipeline, first we need to ingest the data. And that we can do by going into this data sources page. It gives you an ability to connect with your data so that you can create a new data source connection by clicking on this button. And as you can see, there are multiple information that you need to provide to create this data source connection. And two of those are vector database connection and data source, or the embedding model. And now let's create these two first, and then we'll get back to this page to create a data source. So let me quickly go to this embedding models page where we can add a connection to one of your embedding models of your choice. So for this one, I have some data ready so that we can quickly create one. Let me just use that. So we'll click on this add model button and we add this information. We select the provider, then enter the model identifier, and then the dimension of your embedding model. So this is a very important information, the dimension. This makes sure that the data that you're converting your data in the numerical space is in the correct dimension or correct format. And for that, we set this dimension parameter to the model that we are using. So for here, we are using text embedding 3 small model from OpenAI, for which I will use dimensions 1024. As we have tested the connection, looks like it is connected successfully. And now we will add that model to our system. And there we go. Now on the next step, we will use a vector database connection to store our data into. And we can create a connection by clicking on this add connection button. Let me create one by these steps, and I need to provide, now that I've selected a particular provider, so I need to enter this relative information to create that connection. And in Databricks, we need to connect to, when we need to connect to an index, we need to provide catalog and schema information as well. So let's do that. And here's our index. Now we will click on this test connection to test whether we are connected successfully or not. And now that it says we have, and now we will click on this add vector database to get that added into the system. And there we go. We have our own vector database connection ready to use. Now we'll move to the data sources, and we will create a data source connection using these newly created uh, vector database and embedding model. Let me quickly grab this information as well. So this is the new vector database connection that we have created, and this is the embedding model connection that we've created. And now we select the data source type from where we want to ingest the data, and then we provide the information of that data source. So let me quickly paste that information in here. And again, we test the connection just for the surety, and we add the data source. So as soon as we add the data source, what it will exactly do is it will create this data ingestion pipeline, uh, which will do all the work, that is reading the data from the data source, converting that into a vector space using the embedding model, and then storing that information into the vector database, which we have selected at the time of creating that connection. So all that process happens through a pipeline, and all the steps that I've just mentioned will be happening inside it. So this will take some time to complete, uh, hopefully around 3 to 4 minutes, maybe. So just to add more information about this, so this whole pipeline is highly scalable and is capable of uh, processing thousands of files at once, and that too with the higher accuracy because of the selection of different, or the availability of different types of embedding models, and you can choose the most suitable one for your job. So that ability is provided through the selection of embedding models as well as the vector database. So this gives you a freedom of a choice for your vector database, and the settings that you want to do with your embedding models as well. Okay, so the job ran successfully and it took around 3 minutes and 25 seconds to do that. Now let's see where we can use this particular data source that we have just created. And for that, we will go to this Q&A playground where we will be able to chat with this newly created data source. So as you can see, we have selected this uh, new data source along with a model, and you can create your own LLM connections by going into LLM settings so that you will be able to see all those models in here, and you can select the one that you want to use to do the chat with your data. So let's start with it. Let me just quickly change this to this one, and we'll just ask a question here, and that would be this one. So it will do a retrieval and a prompting of this particular question. So what exactly happens is the similarity search algorithm will look for a most similar context from the data set, and it will look for this information, particular information inside the seed documents that we have uploaded. And now, okay, we've got the answer, and it says uh, the answer, the policy's purpose is to set clear expectations for employee behavior towards colleagues, managers, and the organization. And along with it, it also gives us the citation so that we would know how exactly those sources are helping here. So both retrieval and the prompting techniques are being used to find the most relevant information from the data set. So multiple algorithms are there to do this search, along with uh, uh, different metrics being calculated just in case we want to tune them and find the parallel information alongside the data that we are looking into. So this covers the data ingestion part and how we are doing the retrieval and prompting of the question. Now let's move ahead to the evaluation engine and synthetic data. For that, we can go into this evaluation menu where there are two different tabs. One is the user feedback and another is synthetic data generation. So user feedback is basically your uh, the manual intervention from human along with your data or along with your responses that you've got. And here people can give their feedback based on their knowledge and based on their information that they have, uh, and the colleagues from the organization can give the most relevant information about the responses yeah, is what we think. And that's why we've added this user feedback mechanism where people can evaluate these question answers or the responses that we have from the questions, and then they can give their feedback like this, uh, whether the feedback is correct or not based on this like and dislike column. And then they also can provide us the rationale behind their feedback. So this particular information is useful when we are refining the future answers for the similar questions. And all that information you can find on this particular page. So this is particularly helpful when it comes to uh, the feedback from your colleagues about certain information that you've got. And another aspect to this evaluation is the synthetic data generation. So this is a part where you will use the automation to do the evaluation, and that you can do by creating a synthetic data generation for your or creating a synthetic data for your questions. And you can do that by clicking on this create job. Here it will ask how many number of questions you want to generate for your data source. So this is particularly about uh, generating a number of questions along with their answers, which will give you the information about how exactly it have got that answer and what were the expected facts and expected retrieval context, and based on which LLM as a judge will be used here to compare the results with the compare the actual results with the LLM's output. This will give you a confidence. So let me just quickly show you how you can make use of this. So you select your data source and you tell how many number of questions you want to add. Let's say I want to compare only 10 questions at this time, and then I click on this generate data. And now this will again do all the calculations behind the scene, and it will start generating the question and their answers, uh, and expected facts and expected retrieval context. All this information will be gathered first, and then LLM as a judge will be run, and that will do the exact comparison of the the expected facts, whether these expected facts are there in uh, the actual answers or not. And based on that comparison, we would get metrics such as the correctness. You can add more metrics to this. So meanwhile this is running, let me quickly open a different, let's say this one. Let's see how exactly it looks like. So this will open your MLflow UI where you will see all the results from your question generation. So yeah, there we go. So for this particular run, or for this particular data set, when we use the configuration that we have set, it will show us how many of the answers are correctly generated and how many have not. Out of which, let's just quickly have a look how that information is helpful. So when we see the correctness, it's set to no. Here you will get a detailed rationale or a detailed analysis of your uh, question answer pair alongside the expected facts. So this is the information which will be helpful in terms of understanding how you can improve your overall system. So this particular rationale says that the first part of the expectation set states the earned leave is credited at rate of 1.5 days per month. However, the response does not specify any exact accrual rate. So this is the information uh, gathered from these two factoids, and one of them is the expected facts, where it says for this particular question, the answer must contain these four information. And it looks like some of this information is not there in the answer at all, and that's the exact reason this particular answer is marked as not correct. And if we do that same for the one for which the correctness is yes, there we can also see the rationale behind why this correctness is set to yes for this answer, and it will give us the complete rationale about that. So this will completely help you in terms of understanding your data source and how it is interacting with your the question answer generation, and the exact evaluation is done, and that too in the both parts. One is your automated part using the synthetic data generation, and the second one is the user feedback itself. So this gives us a comprehensive evaluation framework uh, for your accuracy of the data. And again, this particular uh, pipeline can be run or is automated to run for every week, so that if there is any CDC happening in the backend, you do not need to worry. This particular pipeline will take care of it, and it will generate the question again, and it will do the complete evaluation on behalf of you, and that will give you all the results in the similar format, which you can use later for improving your system uh, at larger scale. So that's about the evaluation engine and the synthetic data generation. Now let's talk about the governance and UI experience of this application. and particularly talking about the governance, we'll show you here that we have these user management workspace and workspace permissions. So you can set permission to each and every user at a workspace level. So let's say your organization have different departments and they all have a different data sets, and you do not want uh, uh, HR department to access the data from any other department or vice versa. Then in that case, you need to uh, set these workspaces in such a way that you are creating a different workspaces for a different level of accesses. So that you can do using the workspace and workspaces permission. So you do not need to worry about the access control here. So that is completely provided throughout this application, and that propagates to all of the resources. So you need to so whenever you are creating any resource by selecting, let's say, if I'm going into LLM settings and creating a LLM connection, so whatever workspace is selected on here on this top left corner, in that workspace itself, it will create all these uh, connections. So this way you're isolating the resources as well, and you're managing the access throughout the application. And to talk about the UI experience of the application, so we have done all the hard work engineering for you, and you can start using it by getting this set up in your own environment. So uh, that is there, and every component in this UI is neatly tailored to your requirements about the RAG as a service, and you would get all the required tools and the features for completing your end-to-end RAG pipelines and managing them at scale. So I hope that information is useful for you, and if you have any questions, feel free to post them in a webinar chat, so that we are happy to answer those. Thank you.
Great demo, Asutosh. Now that you have seen the system in action, right, from getting the data until towards the answering and also the operation, how it works. Amol, so what happened when organization want to scale beyond having one assistant? If they want to scale to more assistant, what do you want to do?
Thanks, Raj. Once you have built one assistant, the next step is scaling. You want to move to many assistants, and that could happen at a very faster pace in any enterprise organizations. At this stage, shared systems becomes very important. You call it shared or centralized system, it's one and the same thing. You need shared ingestion, shared testing, and shared governance. Quality also need to be checked constantly. You need automated scoring and regulated test runs. If the answers start to drift, you need an alert immediately. So your AI ops engineer can kind of take action on that. Access control remains critical. People should only see what they are meant to see. And audit logs help you track exactly who access what. The logging is so becomes so important here. And finally, AI ops. This keeps everything reliable. It handles monitoring, cost control, and even fixing small issues automatically. This is how you move from just one assistant to many assistants, and finally to full AI platform for your organizations.
Thanks, Amol. So now we are coming to the end of our webinar. Let's try to take some questions. Okay, so thanks team for putting up a lot of questions here. I'm going to take the top 2 or 3 priority questions, and then I'll ask either Amol or Asutosh to answer it. The very first question, why do leaders should consider choosing Cloudaeon RAG as a service, and how it is going to be the game changer in 2026? Amol, I think it would be for you. Can you answer it?
Great question. And the more, like, just to give you some background on that, the more and more I'm talking to leaders in the data and AI communities, the RAG is their number one priority for 2026. And at the same time, like, they want to be a kind of a technology agnostic. They don't want to use the kind of a pre-built solution either. It could be on one platform or it could be on another platform. They want to mix and cherry pick the solution or the technologies which is fit for their organizations. So to do that, you have to build something in-house, and that's where, if you see in the beginning of the webinar, we talk about in-house versus accelerator or RAG as a service, which Cloudaeon has built. What we are proposing here is cutting down your all the 16 to 20 week worth of plumbing work, which we already pre-built, tested, and giving it to you. Right? So you can kind of start delivering value from this accelerator straight away. And the most important thing is data is yours. Hold this RAG accelerator IP sits with you because this will be hosted within your organizations. What we are bringing, our engineering expertise, and the reason we built the accelerator to add and give a value to our customer from day one. So I hope that gives the that clarify this question. Thank you.
Yeah, thanks, Amal. Isn't it very good that you're taking something which is already has been in the production and you're starting not from zero, you're starting from way ahead in the curve. That makes the life much easier. Yeah, and follow up to the same question. There was one more question which came in. It's more about technical. So I'll just ask Asutosh to answer it. So the question is more about if we are going to host within our own organization, there are multiple business units out there. There is a finance, there is an HR. How does your RAG works when someone is asking the question? And how does that data, doesn't comes up for financial data come to everyone? Asutosh, how does it been done in your RAG as a service?
Yeah, thanks, Raj. I think that's more of a access related question. And for that, we have these workspaces created. And for each of the department in an organization, they can create their own workspaces so that all the accesses throughout the resources can be managed through this containers. And uh, permissions related to these different workspaces can also be managed through a workspace permission menu, where you can select and choose the users for each of the workspace who can have access to. So yeah, I think that covers the access part within an organization.
Yeah, thanks, Asutosh. Yeah, so if you look at it, so the data gets segregated and the governance and the data security, which is not an afterthought, which is already has been built within our accelerator or the service. So the data will be for the right person for the right time. It's not going to be mixed across the different source. Okay, thanks, Asutosh. Yeah, there is another question which just came in, which is more interesting. So what happened, for example, you keep on adding multiple documents. The documents keeps on evolving. New versions keep on getting uploaded. How do you ensure that the RAG system doesn't slowly drift in quality over time?
Yeah, thanks, Raj. So that is more of, I think, a CDC problems, a change detection one. And for that, we have this configurable parameter, which automatically creates this frequently uh, a pipeline, a frequent pipeline, where it would go and check for any change detection, and that change detection will then propagated throughout the pipeline, and then only that change data will be then processed and stored into your vector databases. And as long as the quality of this newly changed data is concerned, again, a frequent synthetic data generated pipeline is then run again to generate the question answer pairs throughout this for this new data, and then the quality check begins from there as well. So yeah, I think these two things covers the most part of it.
Yeah, thanks, Asutosh. So the automated pipeline, the CDC change based on the frequency, right? And also the synthetic data generation Q&A that helps it out. Since we are running out of time, we will answer each and everyone's question through email. Before we close, here is one optional next step. If you want to explore your own RAG use case, with your data in your premise to show the value, we are happy to walk through it with you. It's completely optional and there is no commitment. You can reach us hello@cloudaeon.com or through our website. Thank you, Amol, and thank you, Asutosh, for joining in. And thanks everyone from joining from the different geography during the busy schedule, and also Christmas was around the corner. And we hope this session was valuable. Wishing everyone the Merry Christmas and New Year. Thanks all.